Hello everyone, in this video we will be discussing on the system design key concepts part 8, that is fault tolerance. In fault tolerance we will discuss what is fault tolerance, what are the common approaches to achieve the fault tolerance, high availability versus the fault tolerance, normal functioning versus the graceful degradation, setting survival goals, the cost of fault tolerance, fault tolerant architecture examples, and in this example how to achieve the fault tolerance in the application layer and how to achieve the fault tolerance in the persistence layer. So firstly, what is fault tolerance? Fault tolerance describes a system's ability to handle errors and outages without any loss of the functionality. Consider this example. This application 1 is connected to a single database instance and application 2 is connected to two database instances. One is primary database and another one is standby replica. In this scenario, application 2 is more fault tolerant because if its primary database goes offline, it can switch over to the standby replica and continue operating as usual. But application 1 is not fault tolerant. If its database goes offline, all applications features that require access to the database will cease to function. So what are the common approaches to achieve the fault tolerance? Mostly there are three approaches to achieve the fault tolerance. First one is multiple hardware systems, multiple instances of software, and backup sources of the power. In the multiple hardware systems, in the earlier example, in application 2 could have its two databases located on two different physical servers, potentially in two different locations. That way, if the primary database server experiences an error and hardware failure or power outage, other server might not be affected. Second one is multiple instance of the software. It will be capable of doing the same work. For example, many modern applications make use of containerization platforms such as Kubernetes so that they can run multiple instances of software services. One reason for this is so that if one instance encounters an error or goes offline, traffic can be routed to other instance to maintain the application functionality. And third one is backup sources of power, such as we can use the generators in the on-premise systems to protect the application from being knocked offline if the power to the server is impacted. Then we'll discuss what is the difference between high availability and the fault tolerance. High availability refers to the system's total uptime, and it's not mandatory that whenever a system is high available it can be a fault tolerant. A fault tolerant application could still fail to achieve the high availability. For example, it has to be taken offline regularly to upgrade software components, change the database schema, etc. And building a fault tolerant system is more complex and more expensive than building a high availability system. For example, in the earlier one example, application 2 is more fault tolerant, but it also has to pay for and maintain an additional database servers. Thus, it's important to assess the level of fault tolerance your application requires and build your system accordingly. What is the difference between normal functioning versus the graceful degradation? When designing fault tolerant systems, we may want the application to remain online and fully functional at all times. In this case, goal is to normally function that particular application, and you want your application and by extension the user's experience to remain unchanged even if an element of your system fails or knocked offline. And another approach is aiming for what's called graceful degradation, where outages and errors are allowed to impact the functionality and degrade the user experience but not knock the application out entirely. For example, if a software instance encounters an error during a period of heavy traffic, the application experience may slow for other users and certain features might become unavailable. Setting survival goals. Achieving 100% fault tolerance is not really possible. So the question architects generally have to answer when designing fault tolerance systems is how much they want to be able to survive. And survival goals can vary, but there are mostly three survival rules which can be adapted in the cloud in the ascending order of resilience. First one is survive node failure. Second one is survive availability zone failure. Third one is survive region failure. Survive cloud provider failure. So in the survive node failure, running instances of software on multiple nodes with the same availability zone can allow application to survive faults on one or more of those nodes. And in survive exit failure, running instances of software across multiple availability zones within a cloud region will allow to survive the availability zone outages, such as specific data center losing power during a storm. Survive region failure, it's like running instances of software across multiple cloud regions can allow the to survive an outage affecting an entire region, such as AWS US East 1 outage mentioned at the beginning of this course. And fourth one is survive cloud provider failure. In this, running instance of the software both in the cloud and on premise or across multiple cloud providers can allow to survive even a full cloud provider outage. And at what cost the fault of tolerance we should do. So mostly we should answer these four questions, and if it's impacting the too much cost, then we should go for highly fault tolerant system. Firstly, what does an outage cost in dollars? What does an outage cost in reputation damage? Also, what does an outage cost in the engineering hours? And also, what does an outage cost in team morale and the retention hiring? If these four questions are asked, accordingly we can decide the cost of the impact and design the fault tolerance system. Then we will consider the fault tolerant architecture example. So here in this example, there are many ways to achieve the fault tolerance, but we will take the common approach, multi-region architecture built around the containerization services such as Kubernetes. Here in this example, the application could survive a node availability zone or even a region failure affecting its application layer or a database layer or both. And we will see how that can be achieved in the application layer as well as the database layer. Firstly, we will see how the fault tolerance is achieved in the application layer. In this diagram, the application is spread across the multiple regions, with each region having its own Kubernetes cluster. Within each region, the application is built with the microservices that execute specific tasks, and then these microservices are typically operated inside the Kubernetes pods. This allows for much greater fault tolerance, since a new pod with a new instance can be started up whenever an existing pod encounters an error. This approach also makes the application easier to scale horizontally, that is, the scaling we can do, and as the load on the specific services increase, additional instances of that service can be added in real time to handle the load and then remove when the load dies down again and they are no longer needed. So in this way, the fault tolerance is achieved in the application level layer. And how to achieve the fault tolerance in the persistence layer, that is the database layer. So the application in the diagram is similar means in the database layer also we can do. Here cockroach DB is chosen because it's a distributed node based nature naturally provide a high level of fault tolerance and the same flexibility when it comes to scaling up and down horizontally. Being a distributed SQL database, it also allows for the strong consistency guarantees, which is important for most transactional workloads. And cockroach DB also makes sense for this architecture because although it's a distributed database, it can be treated like a single instance Postgre database by the application, and almost all the complexity of the distributing the data to meet the application's availability and survival goals happen under the hood. That's why in this example we can achieve the fault tolerance in the application layer also, and in the database layer also. Thank you.